one particular part of the quadratic formula, and that is called the discriminant. Now, if you remember the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a, this particular expression that is under the square root, it's what we call the discriminant. So the formula for the discriminant is b squared minus 4ac, and there's a notation that we use for the discriminant, and that is a Greek letter delta. So delta equals b squared minus 4ac. Now, just by analyzing the value of this discriminant, which is again the expression under the square root in our quadratic formula, we are able to get some information about the solutions. Now, if the discriminant, which is b squared minus 4ac, ends up to be a number that is positive, that means that the quadratic equation has two real solutions. So we say that we have two real solutions. Next, if the discriminant, which is b squared minus 4ac, right, beside being positive, it can also equal 0. So what if the discriminant equals 0? That means that the quadratic equation has one real solution. And finally, a third possibility is for the discriminant to be negative. And what that means for the solution is that the quadratic equation can have two complex or imaginary solutions. So the discriminant, which is b squared minus 4ac, has an important role in giving us information regarding the type and the number of the solutions to a quadratic equation. Now let's see how can we use this in different problems. Now, the discriminant is used whenever you want to get information about the solution without finding the solutions. So without actually finding the solutions, determine the number and type of the solutions for our quadratic equation. So we don't need to find the solutions, we just need to find the number and the type. That is, we need to find whether we have two or one solution, and whether the solution is a real or complex solution. So what the problem is telling me to do is to find the discriminant and see if it's positive, if it's equal to 0, or if it's negative. And based on this information, I can then draw conclusions about my solution. So let's go back to our example. So our quadratic equation is x squared plus 10x plus 25 equals 0. We need to start by finding the discriminant, which is b squared minus 4ac. Well, from my equation, I know that a is 1, b is 10, and c is 25. Substituting these numbers in the equation, I get 10 squared minus 4 times 1 times 25. So we get 100 minus 4 times 1 is 4 times 25, it's 100. So we get that the discriminant is 0. Now, based on the definition of my discriminant, I know that whenever the discriminant is 0, the quadratic equation is going to have one real solution. So then I come and say that the equation has one real solution. Alright, now graphically what does this mean? Graphically, it means that our parabola is going to touch the x-axis only once. So it can look this way. If it opens up, right, we have a point on the x, or it can go this way if it opens down. Right, so having one real solution means that the vertex is on the x-axis. It's actually only touching the x-axis in one point. Okay, our second example is 6x squared plus x minus 15 is equal to 0. Again, we need to find information about the solution without actually finding the solutions out. So we are looking for the discriminant, b squared minus 4ac. I know that 6 is a, plus x, well, there's an invisible 1, so that's our b, and minus 15, that's our c. So b squared minus 4ac becomes 1 squared minus 4 times 6 times negative 15. Alrighty, well, we might need to evaluate this using a calculator. We get 1 minus 4 times 6 times negative 15 comes out to be negative 360. 1 minus negative 360 equals to 361. Now this is a positive number based on the definition of the discriminant. If the discriminant is positive, we're going to have two real solutions. So then I come and say that the equation has two real solutions. Alright, so all I need is how many and the type of the solutions. Now graphically, what does this mean? Since we have two real solutions, it means that graphically the parabola is going to cross the x-axis in 2 points. It's going to have two x-intercepts. So these are two possibilities for our quadratic function to look like. And the last one, x squared plus 2x plus 5. Alright, so I know that I need a, which is 1, b, which is 2, and c, which is 5. The discriminant in this case is going to be, formula is b squared minus 4ac. We plug the numbers in, we get 2 squared minus 4 times 1 times 5. That is 4 minus 20, which is negative 16. Alright, so negative 16, it's a negative number, and again, based on the definition, when the discriminant is negative, the equation has two complex solutions. So the answer in this case will be that the equation has two complex solutions. Now graphically, if I were to graph an equation with two complex solutions, that would mean that the parabola will not be able to touch the x-axis. It's going to be either above the x-axis or under the x-axis. Alright, so this is how we can use the discriminant to get information about the solution without actually finding the solutions out.